So what's different today is you won't have a variable by itself, so you'll have to do a little extra. So let's do problem number 1, and we'll refer back to our rules. Oh, I know what I need to do. Okay, this is x plus 3y equals 14, which is obviously a line. And we've got negative 5x, and I'm pretty sure that's a minus 6y equals negative 16. This one is substitution. Now, let me go back and remind you, there's 3 kinds of ways that you can have a system with 2 lines. They can cross, that's all of lesson 7. Everyone in lesson 7 has a point of intersection. We also have lines that don't cross at all, and they have no solution, and we have lines that cross everywhere. Well, we're going to do one of each of these today. In your 7, you have 5 that are like this, you have 1 like this, and you have 1 like this. You will not recognize just by looking at them what they're going to be. You have to do some arithmetic, some algebra, and I think it'll come back to you. It did to last fall. The first instruction says, find a variable by itself or can easily be gotten by itself. Now, a variable that can easily be gotten by itself is a variable with a coefficient, that's just the number in front of it, of positive 1. Now, I can't promise you in a college algebra class that you're going to have, you might have problems that have every one of them has a number other than 1 in front of it, and they can get pretty messy. So you do have to be careful. But we stick on the Algebra 2 level, and in every one of these, you don't have a variable already by itself, but I see one that I can easily get by itself. It's always, don't try to do this one or this one or this one. You're going to get messy, messy fractions, and I love fractions, but I sure don't like them in equations. And 90% of the time, you're going to miss it, and I'm not wading through all that arithmetic to find your mistake. I'm going to say, why did you not use the one that had a 1 in front of it? Which one is the variable that has a 1 in front of it? Okay, what's in front of this x? What's in front of this x? What's in front of that y? Everybody help her out. Josie's not the only one that knows that. What's in front of that y? Positive 3. What's in front of that x? Positive 1. That's the one we want. So find the one in every one of your classworks. There will be one with a 1 in front, positive 1. So the next sentence says, get that variable by itself. So we need to go down here, and I'm going to rewrite it. And I need to get it x equals. That's what I want, like you had in lesson 7. Now, all of lesson 7 I didn't like because they were y equals. But we're going to do some x equals today. How do you get that x by itself? What do we got to get rid of? What do we have to get rid of? I can't talk. How do you get rid of a plus 3y? Minus 3y. And I get x equals, and I'm just going to write it like it is, 14 minus 3y. If you commute it, it would be negative 3y minus 14. So now we know that x and 14 minus 3y are equal to each other. Your next step said, put the expression into the other line. So we took that one, wrote it as x equals. Now we're going to take this and put it back right there for x. We put it into the other line for substitution. This looks like lesson 7. So we'll put the 14 minus 3y there. So if I have room, I'll do it right here. Negative 5, open parentheses, 14 minus 3y. Because I have to put parentheses because it's a big thing right there. Then I'm going to bring down my 6y. Oop, that's a minus. That's kind of careless mistakes we make. Minus 6y equals negative 16. I'm going to move my little arrow there a little bit. We're looking for the point where these two lines intersect, if they intersect. This is negative 70. I'm going to do the work for you just for time's sake. And then that's going to be positive 15y minus 6y. I think I better put my glasses on. Minus 6y equals negative 16. Now, I'm going to clean my y's up first. So I've got negative 70 plus 9y equals negative 16. Add add 70. And I get 9y equals 54. Now, I'm going pretty fast on that. That's not new. We've done those. Algebra 1, geometry, algebra 2. If you get right here and these don't divide, you get 9y equals 27. Well, try that again. How about 9y equals 13? Then you messed up. Don't start trying to work it with a fraction. The answers are not fractions. You either copied it down wrong or you have made some careless mistake. Divide by 9. And what is y? 6. Got a calculator, use it if you need to. Point of intersection. It says the y. Remember, you got x, y. The y is 6. Now we have to find the x. These are just like the ones that you have in lesson 6. You cross them and see where they cross. So now we take the y equals 6 and we can go back to, now here's where it's interesting. You can go back and put 6 either there, or you can even go to this one. Now, why would I like this one the best? See, it's already got x by itself, doesn't it? So I can just take that 6 and plug it in for y. The arithmetic's easier. You can do any 3 of them, but for time, that's the quickest one. X equals 14 minus 3 times 6. X equals 14 minus 18. X is equal to -4. So I'm guaranteed that those two lines cross at the point -4, 6. With a calculator, algebra is easy to check. If you put -4 here and 6 here, you'll get -4 plus 18, 14. Check. -4 here is 20. Minus 36 is -16. This has to be true in both of them. That's the classic. That's like lesson 7. Now we've got the 2 special cases, so we're going to go to page 21 and do those. So on page 21, everybody got that copied? Good to go? We're going to write 2 special cases. And something is going to happen every time in both of those. And when we get through with them, one of them is going to be no solution, and one of them is going to be infinite solutions. When you write it down, you won't see any difference. So when we do problem number 2, it is -2x plus 2y equals 4, and it's x minus y equals -6. It does not look any different than number 1. So you would not recognize it as a special case. But I'll show you in both cases, something's going to happen. And when we did it, when we got to it, they remembered it last block. Do you have a variable by itself? Do you have x equals or y equals? I don't see one. X equals something or y equals something? Now listen to my question. Do you have a variable by itself, or do you have one that you can easily get by itself? Yes, and the one you can get easily by itself is the one that has a positive 1 in front of it. Which one is that? Is it that one? That one, this one, or this one? This one. That's a -1. Sometimes you have to. Usually in Algebra 1 we don't. That's more college algebra, bridge math, that kind of stuff. So we want to get that one by itself. How would we do that? How do we get x by itself? You don't want to move the x. You want to get rid of the y. You want to get the x by itself and get rid of the y. And so I add y, and I get x equals -6 plus y. You can solve for any of those variables. So now it says in step 2, take that expression, go back to the other line. So we go back to this one, and so everywhere we see an x, right here, we're going to put -6 plus y. So I'm going to do it right here. -2, open parentheses, -6 plus y, and then bring the 2y, as we talked about going to the ball game. They stay in the ball game with substitution. The equal stays in, and the 4 stays in. Distribute the -2. You get 12 minus 2y plus 2y equals 4. Now there's your big red flag. What's something weird that's fixing to happen? Okay. Okay, the y's are going to cancel out, add out. Is that what you're saying? So those are gone. Now, in both cases, your variables, and I don't know if I like the word cancel, but that's what we said last week. Last block. Your variables will cancel out. I'd probably rather say add out, but as long as you get the concept of what we're doing, this will only happen in the parallel or same line version. So what do we have left? We have 12 equals 4. Now, that being a statement is going to tell us whether it's this one or does this one. And that should ring a little bit of a bell to you. Is that a true statement, or will it ever be true? Will it ever be equal to 4? No, if you got $12 and I got $4, do we ever have the same amount? We do not. That's a false statement. That is not the answer. But if it's a false statement, think about what we're saying. That means that they're not going to cross. They're going to be parallel lines. That's not the answer either, but I'm just giving you some characteristics. If you were to graph it like lesson 6, the answer is no solutions. That means they do not cross. Number 3. 8x plus 2y equals 4. And 4x plus y equals 2. Now, this is the second lesson on substitution. Which one, you don't have a variable by itself, which one do we need to get by itself? That x, that y, that x, or that y. That y right there. We need to get that by itself. To get it by itself, subtract 4x. Okay, x's are gone, and you get y is equal to 2 minus 4x. The rules are on page 18. Now, go to the other line and put that in for y, because that's what y equals. Y is coming out of the ball game. 2 minus 4x is going in. 8x plus 2, open parentheses, 2 minus 4x, close parentheses, equals 4. Now, I'm just trying to get you through for the time. Y'all know the arithmetic. 8x plus, distribute, 4 minus 8x equals 4. Your variables are going to add out, and what are you left? 4 equals 4. Is that true? Sometimes, always? Always true. So that would tell me that these are exactly the same line. If you were to graph them, they would graph right on top of each other, and that means they have infinite solutions. Because it's everywhere. They touch everywhere. It's just one right on top of each other.